engineering rock stars. That's who we have for Mercury Wire. And we all know how special Spencer is. We all have our own rock star niches. Good for you, folks. To my left is Hillary McCarthy, process engineer. Marlene Jaguar, technical support for manufacturing, and Jesus Mendoza, who is an applications engineer. And so would you tell us just a bit about what Mercury Wire actually does?
We are a wire and cable manufacturer. We mainly do custom cable manufacturing there, which means we can we can engineer any type of cable that our customers may need. We have endless applications for the cable. We work in underwater cable, cables for computers, cables for the military. So we also are in the connector business as well, the assembly side, not just the wire. But we're growing. We've been there now for 52 years or so, and we're excited to what the future holds. We're looking at different opportunities now, but wire and cable is our main production there.
And what did you share with the students today?
I guess we did a project with the students. We introduced them to Mercury Wire and what we do. And then we brought the engineering design process to the students and let them design their own mini-bot, a little mini robot. It was made with a pager vibrating motor. So then at the end, after they built their bots, we were able to have a competition to see who built the best bot that could fall off the edge of a platter quickest.
And they must have been excited.
They were very excited.
I bet they enjoyed it.
It was taking the design application process and applying it to the mini bots. And you know, we kept saying to them, because it was a little frustrating, but you know what? That's what engineering is. It's design of experiment. Doesn't work, re-engineer it. What can help? So it was not only hands-on, but it was a lot of thought process and putting it behind it. A lot of applying what they're learning in the school to this process. So I can't believe how amped they were, and they were so creative, so much fun to work with.
All right, good morning again. My name is Jesus Mendoza. We're from Mercury Wire. Present Hillary McCarthy, Marlene Jaguar, Ray Ainsworth, and Brian Gervais. Really excited to be here again. We are a local company. Don't know if you've noticed our sign, Route 9, on near what? What is it, near? O'Hearns. We've been around for about 50 years now. It was started out by Mr. Ken Yard. It is now run by his two sons, Bob and Chris. So do you want to join our journey to be an engineering rock star? Because that's what we are, right? All right, we all turn around. You want to dim the lights a little? Is that good enough? Can you see?
Yeah, sorry.
Yeah, just dim them a little bit so it's better. So we're here to participate in STEM, obviously. What does STEM mean to us? What does STEM mean to you? Anyone would like to answer? What does STEM mean to you, Marlene?
Science, technology, engineering, and mathematics, right guys? That's
Yes.
why we're here?
Yes.
Very excited.
All right, innovation, looking for the next best thing, right?
And that's what we do at Mercury Wire. We always innovate. We don't say no to anything that comes across our customers' requests. We always look at it and try and solve problems. That's what engineering is about, solving problems. You really are engineers, if you think about it. You all solve problems daily, somehow. Whether it's taking the shortest path to get to school or going around snowbanks, you're thinking about problem solving there. So it's in our nature to be engineers and problem solvers, and that's what we do. This is what I mentioned earlier. We're located in Spencer, and we are industry leader in custom wire and cable. Wires are everywhere, but we don't usually, we take them for granted. We don't think about the application. Sometimes, like we have wires to plug in extension cords. We just take it for granted. They're just extension cords, but they have requirements as far as heat and voltage rating and the size of the wires. And there's endless amounts of wires that we can make at Mercury Wire. That's the sign I was talking about earlier. Don't know if it looks familiar. On Route 9. It's a new sign. We just got it a few months ago, maybe. So this is where our wires are used, for instance. We have applications such as plasma cutting or welding. In this case, we brought some samples. We'll show them around later on. In this case, you have a worker using plasma cutting, which is basically very, very hot air that cuts metal. We have emergency lighting wires and cables that we make. Marlene, yeah, she brought something in the back that she'll show later on, emergency lighting that we make cables for. Also, in the robotic pool cleaner business, we have cables that need to float in the swimming pool so they don't get tangled up. So there's some flotation requirements that we have to meet. And I brought a couple of examples. I'll show you later of how one floats and one doesn't. And we'll talk about how we make them to float. There's also sewer and water and drain push rod cables. They're very stiff cables that have to be pushed down with a camera on the end to see what might be clogging some of these sewers and drains. Also water quality monitoring systems. We also work with that to sense any bad quality in the water. And we're also in the medical equipment wire and cable business. We also make some medical cables in-house. There's a lot of cables in there, as you can see. And also oil and gas exploration cables. Many of these have strength requirements because they pull. We have stainless steel or Kevlar wrapped around the cables. And also ROVs, remotely operated vehicle tethers. This yellow cable that we send operating vehicles all the way down with a lot of pressure. They have to be resistant to a lot of pressure also. And some fun facts about wires. Did you know in vehicles, for instance, in a car, you don't see many wires in there, but they're hidden between the panels? And interestingly, we found out how much cable is in a car. Does anybody have any idea how much footage-wise is in a vehicle, an average vehicle?
No guess.
Thousands. Thousands.
You ready?
Here we go. Yeah, it's about 5,000 feet, which is about a mile of wire. So that's a lot. I mean, I was surprised too when I saw that. And you can see where the cables go. You don't ever see them because they're hidden, but that's before you make the car. How about a jetliner, like a 747 jet? Any idea? If a car has about a mile, how many miles do you think an airliner has of wires? Yes?
About 3 miles of wires.
3 miles, wow, good guess. Anyone else? There's a prize, right? There's a prize, whoever gets this? No? Is there a prize?
Yeah, we were astonished, guys, at the amount. So.
All right,
Hold on to your hat.
we'll see. 900,000 feet, which is about 170 miles according to Boeing, because Boeing gave out that information. They're the ones that make the jet.
Job security.
171 miles. Wow, I was surprised also. Does anybody have an idea what these are? Yes.
Cell phone towers?
Yes, they are. Cell phone, wireless, right? They must be wireless for the wireless cell phones, obviously. So these require wires also. So people say, hey, wires, they're going to go obsolete. No, even with wireless, we still need wires somehow. So these cell towers have a lot of wires in them. I don't know if you can see. They go all the way to the top, and these cell towers can reach up to 200 feet or something. And they have many, many, many wires in them. That's fine. All right, so the engineering design process. We have a little project we're going to have you get involved. It'll be fun. It's very simple, but it teaches you the basic wiring methods and just the basic circuit knowledge that we'll go through. It involves a little motor, a diode, and batteries. But this is what you'll be encountering today. You have to define a problem, do some research on it real quick. and then do some specify the requirements needed. For instance, you need 2 batteries in this case. Brainstorm solutions, choose the best solution, do development work as a team. We'll build the prototype, we'll test and design, and then hopefully have a little race. These things will move around, they'll shake. So we'll put them in a panel. I think there's you brought the panel? And we'll have a little race, and there's another prize, right, for that? Whoever wins that, no?
The biggest applause ever, guys. That's what you're gonna get. Woo!
Yeah. All right, so we'll have a running slide of what the inside of our factory looks like.
And how wire is made.
And how wire is made, exactly. Well, the copper wire we don't make. We make everything else after that. We buy the copper wire, different sizes, different strand counts. But we do manufacture the cables, putting the plastic over the copper wires. And some of these are silver. That's a braiding machine. That'll braid Kevlar or braid copper on a cable. Like shoelaces are all braided. They were all made on something that looks like that. Whoever has shoelaces nowadays, they have shoelaces, right? They haven't come up with anything? All right. And that's a buncher of cables. We call these bunchers or cablers, where we put them all together. And then we apply some jacket over it to protect the cable, different types of plastics, tapes, and just an endless amounts of materials that we could apply to meet our customer needs for every different application. So these cables that we brought here today are all related somehow into what we talked about. This is like the sewer cable that was up there. This is very stiff. It has a fiberglass rod that enables you to just push it without breaking it. And the emergency lighting has our cable, which is this one. And these are the 2 flotation cables for the robot cleaner that we showed on the slide. So one of these will sink, one of these will float. So I'll do that demo now for the robotic swimming pool cleaner. So I don't know which one will sink, which one will float. I hope they don't both sink. All right, here you go. The reason that sinks is because the jacket, when we extrude the jacket over the cable, we also have the ability to have it apply more air, have more like air cells inside the jacket that allow it to have a specific gravity less than 1. So specific gravity, anything less than 1 will float, and anything greater than 1 will sink. So this one has a specific gravity that's less than 1. That one has more than 1.
And the angle slot. I'm thinking.
Still working. Right. Throw this water out.
Now I'm not sure what order you put the batteries into. Put them positive to positive, negative.
Hopefully it fits snug in there.
Doesn't matter
So
how
just
you lay
stack
it.
them. Yeah, you just stack them. Yeah, that's good. Does that work out good? Wow, it's good.
Yep, that's your motor. The little blue thing is your
As long as they're not touching, which I think you got it.
right?
Oh, now you go. So if you separate these a little, you can avoid them from touching. You don't have a short circuit.
Yeah.
Perfect.
Oh, good.
Which one's the long one?
Stuff in between the battery and the core. Core's not working. Here it is. Yeah. Just without touching any of the other wires.
Stab it in your hair.
Otherwise, we're getting. That's the negative. So negative should be the bottom side of the battery. Then it messes them up. It cuts off the wire.
Good, it's moving. Everybody ready for a race?
Not a good wrapper, I guess. Step past 18!
Stopped at 5 feet, so it automatically stopped, and the light came on just to tell us that. To reset the footage to run again. Just buttons to show now with touchscreens that are fairly inexpensive. We can do stuff that we used to have to do with a manual button. Or you can change the